السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي مع منصة البث المباشر وزارة التربية والتعليم المصرية. معكم مستر حسام حسن. We start now our session about chemistry. Now in this session we start the coordination bonds. We have in the last sessions and we explained the bonds and we classified these bonds according to the behavior of bonds into physical bonds and chemical bonds. And the chemical bonds will types into many things. First one is ionic bond, covalent bonds, and coordinate bonds. Now our session in coordinate bonds. And this physical bonds is metallic bond and hydrogen bond. Now in discussing for this coordinate bonds. What the meaning of coordinate bonds? Coordinate bonds is a type of a covalent bonds, but it's not covalent bonds, but it's a type of covalent bonds. Because the covalent bonds, when we discussed before, we know this important thing, the two electrons in the bonds consists of two atoms. Each atoms share by one electron from them in the valence electron, okay? But in here, in coordinate bond, the bond pairs from one source only. If I ask you what is the difference between pair bonds or bond pairs and coordinate bonds and covalent bonds, the answer is bond pairs and covalent bonds, it's sourced from two atoms. But the two electrons or bond pairs in the coordinate bonds from one source only. So the coordinate bonds is a type of a covalent bond which differs only differ only in the origins of the electrons pair which is shared between atoms involved in the covalent bonds. The electron pairs forming the ordinary covalent bonds is produced by both of two combined atoms. I illustrated this before. Now, these atoms contributing one electrons to the bonds, whereas the pair of electrons occupying one orbital found in one atom called the donor atoms. Now I have a conditions for these atoms, which donor atoms and the acceptor atom. The donor atoms, it is the atoms have lone pair. Acceptor atom, it is ions have an orbitals or empty orbitals, no electrons in this orbital. Now we can discuss of these meanings for this bonds. Now this lone pairs is donated to the another atom. I have two electrons like nitrogen, like phosphorus, like oxygen. Any atoms have lone pair of electrons have an ability to donate these electrons to make the coordinate bonds. This lone pair is donates to another atom having a vacant orbitals, needing this electron pair to acquire the stable electrons configuration. This atom is called the acceptors. So the source of coordinate bonds is one atom. Now, I repeat this. You must focus on these words. Number one, the covalent bonds. The covalent bonds. It's two atoms shared by this bond. Each atom shared by one electron or a number of electrons like the other. But the coordinate bonds, one atom not share but donates two electrons. This axis of electron, this lone pair doesn't share with any bonds. So I call it coordinate bonds. Now, we find the explanation of H3O. This is a hydronium ion. What the meaning of hydronium ion? It is a stable compound? No, it is not a stable, because I find this coordinate bonds is not stable. The hydronium ion represented chemically as CH3O. H3O, I have positive H3O positive. This is plays a vital role in acid base. What the meaning of H3O? If you have HCl, H2SO4, H3PO4, any acids, when these acids soluble in water, acids will dissociate into two types, H positive and the anion negative. H positive form coordinate bonds with H2O water molecules. These water molecules have oxygen. Oxygen, when you make an electronic configuration of oxygen, okay, help me by using your paper and your pen, write this electronic configuration O8, okay, 2s2, 2b4. Now you have 4 electrons. 2 electrons and S, these 2 electrons are lone pair. Now 2bx2, this is lone pair again. 2by1, 2pz1. Now I have 2 electrons. These 2 electrons form 2 covalent bonds, H2O. Now I have H3O. Okay, H positive accepts 2 electrons, lone pair of electrons from the O and forming the coordinate bonds. Okay, that has gains. Now you find this hydronium ion chemically, basically H3O, plays a vital role in acid-base chemistry. It's essentially the water molecule H2O that has again an extra protons H positive, where H positive is forming from dissociation of HCl or any acids. Okay, this happens when acid dissolve in water. Now, and release protons. These protons don't exist independently. They interact with water molecules to form hydronium ions. But I want to note very important things. Hydronium ion, it is a not stable compounds. May dissociates into H positive and H2O another. How is bonds formed? I illustrated before these formations of the coordinated bonds in the hydronium molecules forms the sharing of 2 electrons from oxygen and donate oxygen, 1 lone pair, 2 electrons, and lone pair to H positive. It is a proton. These coordinate bonds in the hydronium molecule forms due to the presence of a lone pair of electrons on the oxygen atom. You find here, when you make electronic configuration of oxygen, you find you can to make distributions 2, 2, 2, and have 2. What the meaning of 2, 2, 2? I hear 1 oxygen share by 1 with hydrogen here, and 1 of oxygen share with hydrogen and covalent bonds. Now we have 2 covalent bonds, and I have 2 lone pairs. One of them donate of hydrogen. Hydrogen have empty orbital, not accept. This is acceptor, not a gain of electron. Hydrogen here, not gain of electrons, but accept of electrons. Oxygen here, not lose of electrons, but is donate. What the difference between losing and donating? Losing is an important thing for the metal. When the metal reacts, it lose 1, 2, or 3 electrons to reach the stability forms like argon, neon, helium, any inert gas, closest to the any inert gas structures. Now, here is different. We have donating of electrons, not losing of electrons. You must differentiate between the covalent bonds and coordinate bonds. You must differentiate between losing electrons from the metals and the donate the electron from the non-metal. As due to the presence of lone pair of electrons on this oxygen atom, which is acid protons, accepts the lone pairs of electrons to forming the coordinate bonds as illustrated in this form. You find here, this is forming H3O. I have one lone pair doesn't share. Now, this is lone pair is found here, not making, but making coordinate bond here. This is, what is the difference? By U-shape, you have two identical electrons, two different electrons, In two different electrons, here you find this equivalent bond, this is a covalent bond, this is a coordinate bonds. Okay, do you understand that's the differentiate or the difference between the coordinate bonds and covalent bonds? But you must know that the coordinate bonds is a type of a covalent bond. It's like it. It's similar, but not identical. Similar, but it is not identical for that. I have an example, another example. I have NH4 positive, our ion forming ammonium group or polyatomic group. Its name is ammonium group, NH4 positive. How it forms NH4? Now I have ammonia gas, NH3. When it reacts with HCl or H2SO4 or water H2O. Now, if you make electron configuration of nitrogen, you write in your paper, please, N equals 7. The electron configuration of nitrogen is 2s2, 2p3. Now, you have 3 single electrons in the orbitals p, but I have 2 electrons in orbital C, S. This S, it is not shared by using the covalent bonds, but you have a lone pair of electrons in orbital S. I have 3 single electrons in the orbitals in P, X and Y, Z. Now, each electron of nitrogen making covalent bonds. But I have lone pair, these lone pairs making coordinate bond. Now, the formation of the ammonium ion NH4 positive involves the bonding of ammonia NH3 with a hydrogen ion H positive. Here is step-by-step explanation. Now we repeat this again. Ammonia is a lone pair, ammonia NH3 is a molecule with a nitrogen atom at the center. Now, this nitrogen atoms has a lone pair of electrons, making it capable of forming a bond with additional proton H positive. Now, in the next slide, we have an examples for this is ammonia gas. Ammonia gas reacts with hydrogen positive, making these formations of ammonium ion. Okay, it's formed that of ammonium ions. Interaction with the protons when ammonia encounters free hydrogen ions, H positive, often presents in acidic solutions. It attracts the protons due to its lone pairs of electrons. Coordinate bonds formation, how the lone pair of electrons on the nitrogen is donates to the protons, creating a coordinated bonds or coordinated covalent bonds. This results in the formations of the ammonium ions. Now, where is the ammonium ion formation? When ammonia gas reacts with water, forming NH4OH. When ammonia gas reacts with HCl forming NH4Cl. When ammonia gas reacts with H2SO4, it's forming NH4 by 2SO4, ammonium sulfate. Now I have many difference for these compounds. I have many types of bonds. I have an ammonium NH4OH. I have ionic bonds, and I have covalent bonds, and I have coordinate bonds. Now we have ammonium ion formations, a structure of ammonium ion. The ammonium ion NH4 positive consists of nitrogen atoms at the center bonded to 4 hydrogen atoms in a tetrahedral arrangements. Since the protons doesn't contribute electrons to the bonds. Okay, it gives the ammonium ions its positive charges here. This is lone pair here. Lone pair of electrons and have 3 bond pair. When nitrogen forming 3 bond pairs with 3 hydrogen. And I have lone pairs. This lone pair share this H positive, forming NH4 positive. Now it's forming the coordinate bonds with formation NH4 positive. Now I finished all chemical bonds. Okay, review with me types of bonds: ionic bonds, covalent bonds, coordinate bonds. Focus with me, please, to understand and to review. That's with me. You have ionic bond. Ionic bond forming between 2 ions, not 2 atoms. Focus for my expressions. 2 ions. Positive ions and negative ions. Next, the attraction force between electrostatic force between 2 ions forming. The difference in electronegativity between these ions equal to more than 1.7. By increasing the difference in electronegativity between these ions, the strength of ionic bonds increase. So melting points, conductivity of electricity, solidity of the compounds, they are depends on the strength of these bonds. And the strength of these bonds depends on the difference in electronegativity. Now I have an example in ACl, KCl, K2S, Fe, F, and another examples. This example explains what the difference between types of, or the strengths between them in ionic strengths. The other covalent bonds, I have covalent bonds. I have many types. It classifies into 3 types: pure covalent bonds, polar covalent bonds, and non-polar covalent bonds. Covalent bonds forming between 2 atoms and more. One of them shared by a number of electrons and the other shared the same. And in the pure, we have 2 identical atoms like O2, H2, N2, Cl2, F2, and the other. The difference between them and electronegativity equal to 0. So it is pure covalent bonds. I have nitrogen N2, each one shared by 3 electrons, so it is a triple bond forming between N and O2, OO. It is forming 2 double bonds between OO because oxygen shared by 2 electrons of each of them. And hydrogen H2, H single bond H. This is forming between H and H. This is bonds is single bond. Now I have 3 types of bonds between them, and these bonds forming the differentiations between these bonds. Okay, I have polar covalent bonds. The polar covalent bond, the difference in electronegativity less than 1.7 and more than 0.4. But non-polar equals to between more than 0 and less than 0.4. Now we have many examples like CO2 is a non-polar compound, CH4, C2H2, C2H4. So I have many examples for that, and I have many theories explain or illustrate the formation of covalent bonds like octet, VSEPR, and VBT. This theory explain the formations, the covalent bond according to its view. Okay, now we'll transfer to physical bonds. I have many types of physical bonds, hydrogen bonds, and I have metallic bonds. Okay. Basically, I have hydrogen bonds. It is known that water boils. I ask you now, it is known that water boils at 100 degrees. I ask you these equations. Okay. Why? Because this is a temperatures is considered to be high for a compounds of low relatives molecules mass 18. Now I have 18. This is molar mass of waters, but its boiling points equal to 100. Why? I knew before the relations between the boiling points of the compounds or of the substance and the structure of this and molar mass of this. I have molar mass of H2 is little, is 18. How it boils at 100? Okay, I have cause. What is cause for that? If we compare this with the boiling points of hydrogen sulfide H2S. Now, hydrogen sulfide is a gaseous structure. Its weight equals 3-4 gram per mole. We find that is negative 61. How is make? Negative 61 of H2S when its molar mass equal to 34 and waters equal 18 and its boiling points equal to 100. How it's make? Explain me how that. What is the reason for that? Now I have reasons for that. I call this is anomalous of boiling points of waters due to higher electronegativity of oxygen 3.5 than hydrogen 2.1. Okay, you have a very important things for the explanations for this formation hydrogen bond. Hydrogen bonds is a physical bonds. It's forming this as a result of a difference in electronegativity. So water's molecule is said to be polar molecule. The oxygen atoms in waters carried a partial negatively charge, while the two hydrogen atoms carry a partial positive charge. Now I have many important things to understand that. Okay, this is a result of the high difference in electronegativity between the two atoms. Now we have two hydrogen atoms carried a partial positive charge as a result of the separations of charge in water molecule. Now, results of the difference in electronegativity, so the water's molecules says to be polar molecule. The oxygen atoms in waters carries a partial negative charge, while the two hydrogen atoms carry the partial positive charge. Now, results of the separations of charging in the water molecules find here forming the attraction forces between together by what is known as hydrogen bond. Hydrogen bonds, there's no sharing of electrons and no electrons here in the hydrogen bonds. Hydrogen bonds, it is attraction force only. It's attraction force between oxygen and hydrogen. Because I have partial positive charge and negative partial charge in oxygen, this attractions together by what is known as hydrogen bonds and or hydrogen bridge. I have the bridge between the two atoms. Hydrogen bonds forming between hydrogen atoms binds by polar bond like NH, OH, HF. What's the difference? I have S and H. No, there's no. Why? Because the difference in electronegativity is very low. Now there's no hydrogen bonds in HS, but I have an NH, an OH, and HF with a high electronegative bonds atom like NOF. I concentrated of this group 7A, 6A, and 5A. I have these atoms high electronegativity. So H forming with F, with Cl, with Br, and oxygen with hydrogen, nitrogen with hydrogen. This is forming the bridge. This is a bridge. If you focus on the structures of compounds, I have H2O and H2O, and I have hydrogen bridge between two H2O by using this bridge. This bridge between H positive and O negative. The hydrogen atoms becomes a bridge between two oxygen atoms of high electronegativity. The molecules get near to each other, so that we can say that these hydrogen atoms binds the water molecules together. Hydrogen bonds are a type of intermolecular forces of attractions. Now, this is intermolecular force. I call it is hydrogen bond. Hydrogen bonds, we can account the boiling points of waters by the facts that the heat energy is used up dissociating the hydrogen bonds between water's molecule. Also, the hydrogen bonds clearly affects the physical properties. Its bond strength is far weaker than the normal chemical bonds. The following table shows the differentiations or difference between the covalent bonds and hydrogen bonds. Now, the covalent bonds is a chemical bonds, but hydrogen bonds is a physical bonds. It is no electrons sharing between this bridge between H positive and O negative. Now, we transfer for this is bond length of covalent bonds is 1 angstrom. Hydrogen bond is 3 angstrom. Now, if you make boil of water, the covalent bond doesn't associate. Doesn't dissociate, but the dissociations makes of what? Of hydrogen bonds. So I need 418 kilojoule per moles. But here I have 1 kilojoule more per mole. I need very little heat to make dissociations of water hydrogen bonds. It's clear that the hydrogen bonds is much weaker than the covalent bonds, and is longer than it. Okay, it is longer. I have 3 angstrom, but covalent bonds is 1 angstrom. So the longer of these bonds help us to dissociation from this. It is longer than when hydrogen lies in straight lines with the polar covalent bond. Now, hydrogen bonds, as in water's molecules H2O and hydrogen fluoride molecule HF, and as electronegativity difference between the hydrogen atoms and the other atoms binds with it. Okay, I have factors. These factors affect the strength of hydrogen bond. Firstly, the difference between the two atoms in electronegativity. So the other atoms bind to increase the polarity increases for covalent molecules which have hydrogen bonds between them. The hydrogen bonds may be of several forms, i.e., the molecules may form a straight line, a closed ring, or an open net of hydrogen bonds as hydrogen fluoride. Now we can show that for this to know the differentiations. This is a cycle. This is another shape for this is the closed ring hydrogen, and we have a straight like that, and I have another shape or like that. This is of shapes I explained before. It is a straight lines and closed ring or an open net of hydrogen bonds in hydrogen fluoride molecules and water. Now this example illustrated the hydrogen bonds and the strength of hydrogen bond. Now, what is the meaning of this bond? I will illustrate it. I have the metallic bond. What the meaning of metallic bonds? Metallic bonds found only in metals. But it is not chemical bonds, but it's a physical bonds. Metals depends on metallic bonds according to the number of the valence electron, because the attraction force forming these metals and the number of valence electrons building by the metallic bonds and the strength of this metal. Each metal has a crystal lattice with a definite form, in which the positive metals ions take a certain arrangements. The outermost shell electrons of each atom are associated together, forming an electron cloud B with free movements to bind these great collections of positive metal ions. This is attractions between these components inside the atoms is forming metallic bonds. This means that the metallic bonds is produced from the electron clouds be the valence electrons, which decrease the repulsion force between the positive metals ions in the crystal lattice. These free valence electrons account for the good electrical and thermal conductivity. Yes, metal or metallic properties increase or decrease by increasing the properties of metallic bond or decreasing the metallic properties of that. These free valence electrons account for a good electrical electrons, and the metal atoms play a role in the strength of the metallic bonds. As the number of valence electrons increase in the metal atoms, the atoms become more strongly bound, and according the metals becomes more hard and has a higher melting point. This is evidence when it's comparing the properties of the sodium, magnesium, and aluminum, these metals of third period. I have many difference in the types. I have difference in the strength of these metals in boiling points or melting points or the conductivity of electricity. We find here sodium metal, the outermost shell or number of electrons in the outermost energy levels equal to 1. Now, it is soft, hardness is soft, equal to 0.5 scale, a small scale. More scale as a scale for solidity of any metal. Now, the melting point is equal to 98 degrees centigrade. Magnesium equal, the valence electrons equal 2, so it is mild. 2.5 equal 650. And aluminum is more solid because it have 3 electrons, 3 valence electrons. The 3 valence electrons is very hard, 2.75, 660 degree centigrade. Now, if you find this attraction between the positive and negative inside the metal, this is attraction force forming this solidity between sodium, magnesium, aluminum, and other of the things. Now we need to discuss some things for the solving some questions before I finish my session. Now, this question, the following choices for the this equation. Now, I have when electronegativity difference between two atoms is 2, what type of bond can be predicted. Now we have the 2. Okay, this is 2. This means I have what? I have this ionic bond. I have an ionic bond. Okay, number 2, if two atoms are bonded as one of them donates pair of electrons to the other, what type of bonds is here? It is the coordinate bond. 3, which of the above bonds explain Motors abnormally high boiling points? It is hydrogen bond. Now, which of the above bonds has its strength dependent on the number of valence electrons equal to metallic bonds? Okay, upon the end, which bonding electrons spend the same time in the valence shell of each of the two bonds stem is pure covalent bonds. What is the type of bonds in root? It is a metallic bond. Now, this is question predicts which solid in each of the following will have a higher melting point. Explain your answer. NaCl or CSL according to the electronegativity or difference between the CSCl more than NaCl because the strength of ionic bonds of CSCl is greatest. Now K and Ca. Ca is more than K because the strength of metallic bonds of Ca is the greatest because number of valence electron in Ca equal to, but in K equal to 1 if you make electron configuration by using a metallic by using the atomic number. Magnesium chloride or aluminum chloride and the MgCl2 more than AlCl3 ionic bonds because the difference between them of electronegativity AlCl3 is less than MgCl2, so MgCl2 is more than AlCl3 because the strength of ionic bonds between MgCl2 more than AlCl. I mean it is the greatest. Okay, which of the following compounds could be able to form hydrogen bonds between its molecules? Okay, I have CH3NH2, NH2OH, and CH3COOH because the hydrogen bonds depends on the difference in electronegativity. Now I finished my session and thank you for this good listening and I will see you next session inshallah. Wassalamu alaikum wa rahmatullahi wa barakatuh.